This section will finish up looking at history of atomic theory, and we'll look at atomic bonding, look at ions, and naming compounds and writing formulas. Start out by looking at the history of parts of the atom. J.J. Thomson played around with cathode rays, and he determined that cathode rays were actually negative particles, streams of negative particles. He called those particles electrons. He was able to identify the charge to mass ratio, but he could not separate those two values. That fell to Millikan with his oil drop experiment, and with that he was able to separate the charge value from the mass value of an electron, and so we can thank him for determining the electron charge. Ernst Rutherford, with his gold foil experiment, determined that a nucleus of an atom is a very tiny portion centrally located in an atom, and that is almost all of the mass of the atom. It's positively charged, and the rest of the atom is primarily empty space. When we put atoms together to form ions and compounds, we can combine them in a couple of different ways depending on the atoms involved. We can create either covalent bonds or ionic bonds. When we create covalent bonds, the electrons between the two atoms are shared. Covalent bonds can exist in solids, in liquids, and in gases. When we create bonds and electrons are transferred, or we create an ionic bond, ionic bonds can only exist as solids. There are no ionic liquids, there are no ionic gases. Ions are used to make up compounds. When we have ionic compounds, you have an ion sheet listing all the common ions, positive and negative. You need to know these. You need to know the names, you need to know the charges, you need to know the symbols of these ions, as well as you know the alphabet, your phone number, and your address. When these compounds are put together to form formulas, there are a variety of patterns. When I have a metal combining with a negative ion, and I want to name it, I'm going to name the metal, not change anything, and I'm going to name the anion. If the anion is an element, I need to change the element's name so it ends in IDE. For example, sodium and chlorine give me sodium chloride. If I'm naming a metal and a polyatomic ion, well, you know the polyatomic ion names already, just put those together. For example, potassium nitrate. If we're working with transition metals, you need to make sure for the transition metal that you identify which charge of that metal you're working with. The way you identify the charge in the name is you use Roman numerals, and the Roman numerals tell you the charge on the metal ion, not how many of them you have. If you're working with two non-metals to form a compound, you use prefixes to tell how many of each element you have in the compound. If you only have one of the first element, then you don't need to use a prefix. Just name that element. For the second element, you use a prefix with that element regardless of how many you have. Even if you only have one of them, you still need a prefix. The name of the second element, then the ending is changed so that you end this name with IDE. A couple of different kinds of acids. Binary acids are acids containing hydrogen and one other element. Usually that other element is a halogen. The formula is HX. To name it, you're going to name it hydro, stem of the other element ending in IC, acid. Example, hydrochloric acid. The X, the second element in binaries, again is usually a halogen, can also be a group 6 element. So hydrotelluric acid, hydrosulfic acid. The other type of acids are going to be polyatomic acids, more than 2 atoms involved. Usually these are oxyacids. No hydro involved here. When you name an oxyacid, you take the stem of the anion, you change the ending of the anion's name based on what the ending is. So if it's an ATE ion, you're going to have it as an IC acid. Sulfate ion gives us sulfuric acid. If the ion has an ITE ending, it's going to be an US acid. Nitrite becomes nitrous acid. You need to be able to name compounds, write their formulas from names.